In this lesson, we'll go over the distance and midpoint formulas and also talk about the equation of a circle. So here in the xy plane, I have three different points. This is -2, 1, 2, 4, and 5, -6. I want to find the distance between these 2 points and then the distance between these 2 points. The formula for distance is the following. If you're given 2 points x1, y1, and x2, y2, d, the distance, is equal to the square root of the difference of the two x values squared added on to the difference of the two y values squared. So let's try that first for these 2 points. So that is -2, 1 and 2, 4. That's my x1, y1 and x2, y2. So here the distance is the square root of, we first take the difference of the two x values. So I'm going to go 2 minus a -2. So that's 2 minus a -2, and then you square that. We add on to that 4 minus 1, the difference of the two y values. All right, so the distance, when I simplify this, we have 2, well, that's really 2 plus 2, so it's 4 squared. And then the next one is 3 squared. The distance is the square root of that 16 plus 9. That is the square root of 25. And so our distance is 5. So that's the length from here to here. That's a total of 5 units, whatever they happen to be. Okay, let's try that again for the distance between these 2 points. So from here to here. That is, what is the length of this line? Okay, so to compute the distance, it's the square root of, okay, I'll do the difference of the two x values this way, 5 minus a -2. So 5 minus a -2, and you square it. And then the difference of the two y values is -6 minus 1. And we square that. All right, so simplifying this a little bit. Okay, 5, well, it's really 5 plus 2, so that is 7 squared. And added on to that is -6 minus 1, well, that's -7 squared. I'll continue my work over here. The distance is, all right, so that is the square root of, well, they're both going to be positive, so it's going to be 49. And when we square this negative, it's positive, so we get another 49. And if we simplify that, okay, 49 plus 49, 98. If you take the square root of this, it doesn't work out perfectly that you get an integer like we did last time. I got approximately, so when I type this into a calculator, this was roughly 9.9. So that's not the exact answer. The exact answer is the square root of 98, but it's about this many units. Even though this answer is not an integer, I think we can reduce it a little bit with the square root. By that I mean, are there any perfect squares within the number 98? And the answer to that is yes. 98 is 2 times 49, which makes sense because 98 is the sum of 49 and 49. But here, you can take the square root of the first number and the square root of the second. And the square root of 49 is 7. So that is, this simplifies to the square root of 2 times the square root of 49. But the square root of 49 is 7, and this will stay under the square root. I'll put the 7 first, so I'll say it's 7 multiplied by root 2. This can't be simplified anymore, so this would be the exact answer. So that was 7 root 2 is this length here, and that's about 9.9. In example 2, we're going to use the same points as in example 1, but now we're going to find the midpoint instead of the distance between them. Let's start with these 2 points here. What is the halfway point between -2, 1 and 2, 4? So where is that located? I mean, I'm guessing it's probably on the y-axis, so right about there. The answer has both an x and a y coordinate since it's a point. So let's talk about a formula for this coordinate. If you have 2 points, x1, y1, and x2, y2, and you want the midpoint, what we will do is average the x values and average the y values, because we'll be finding the halfway point between the x's and the y's, and it should give us this point here. So let's try that with these two. This will be my x1, y1, and this will be my x2, y2. So starting there, let's see. If I average the two x values, that's -2 plus 2 over 2. So that is, I add those two numbers and divide by 2. And I do the same thing here. I add those two y values and divide by 2. So that would be 1 plus 4 over 2. And, well, for that first one, -2 plus 2 is 0 over 2, and 4 plus 1 is 5 over 2. And that reduces to, you can leave it as a fraction, but I think I'll go 0, 2.5 as a decimal. And that looks about right. I mean, this point is roughly at 2.5 for y, but it is certainly at 0 for x. So that is the answer for the first one. So there it is. This is the point. Okay, that is 0, 2.5. Now, what about the midpoint between this point and this one? Not really sure where that is. Maybe it's roughly there? That could be off a little bit, but something around there. Okay, what we're going to do is use this point and this point within this formula. So this time, if we average the x values, that is -2 plus 5, and we divide that by 2. And then the y values is going to be 1 plus a -6 over 2. Okay, so -2 plus 5 is 3 over 2. And 1 plus a -6, that's -5 over 2. Those are reduced. That is an acceptable answer, but we also could use decimals. So 3 halves is 1.5, and -5 halves is -2.5. So either of those would be a fine way to write the answer, like this or like this. And I mean, that's about where I drew this point, 1.5 down 2.5. And I'll just label it again down here. So that's 1.5, -2.5, and this is our midpoint. The equation of a circle with radius r and center hk is given by this formula here. I'm going to copy it down again. So that formula is, it's x minus h squared plus y minus k squared, and that's equal to r squared, which is the radius. By the way, where this formula comes from, if you take the square root of both sides, well, on one side you get r because the square root of r squared is r, and on the left you have the square root of x minus h squared plus y minus k squared. It doesn't quite look like it, but this is the distance formula. This part is the x2 minus x1, and this part is the y2 minus y1. Essentially what the distance formula is saying is you want all of the points xy, so I'll put a point here, I'll call it xy, and here the center of this circle is at 0, 0. We want all of the points xy that are a distance of r away from 0, 0. And this is the formula that you can use to figure that out. So essentially what I'm going to do is take the information here, plug it into this formula, and see what we end up with. All right, so r is equal to 1, and the center h comma k is equal to 0, 0. In the formula for the circle, we get x minus 0 squared plus y minus 0 squared is equal to 1 squared. We can simplify this. I don't need these minus zeros. In fact, I don't even need the parentheses. Here we're just squaring x, and here we're squaring y. 1 squared is also equal to 1, so this thing really reduces nicely to x squared plus y squared is equal to 1. If you go to Desmos and enter in this equation, it'll give you this circle. And what this equation is saying is you're finding the distance between 0, 0 and xy, so r is always equal to 1, and these are all the points that make that true. So let's do the same thing, but with a slightly different circle. This circle here that has a center at 5, 2, and a radius of 2. Here the radius is 2 because the distance from the center to the circle is 2 units. All right, so if we want the equation, r is 2, the center 5, 2 is equal to what we're calling h, k. And if we plug that into the formula above, we get x minus 5 squared plus y minus 2 squared is equal to the radius is 2, and we're squaring that. There's nothing really left to simplify. Certainly you could square these two terms out. The only thing I'll change is write 4 instead of 2 squared. So here's my answer. It's x minus 5 squared plus y minus 2 squared is equal to 4. In fact, it's kind of nice to leave the answer like this because you can see where the center is located. It's the x and the y value that make these two terms equal 0. And the radius will be the square root of 4, which is 2. One last thing, what is the domain and range of this circle? The domain is all of the x values. So I'll call that d is equal to. So all of the x values for this circle, they go a distance of 2 from 5 in both directions. So this is the smallest x value, and that appears to be at 3. And the largest x value appears to be at 7. And we get every single value in between 3 and 7. So for this reason, the domain is the closed interval from 3 to 7. Here I'm using brackets instead of parentheses. Now for the range, which is the y values, call that r. The smallest y value is down here at 0, and the largest one is up here at 4. So this is the smallest, this is the largest, and you get everything in between because that's where the circle lies. We'll write this as the closed interval from 0 to 4. So I'm using brackets because we're including both 0 and 4.